Okay, in the previous video we got the EMF due to electromagnetic force, the electromagnetic force. Remember, there's an electric force and a magnetic force. So F over Q is E plus V cross B. So these are the two terms that contribute to an EMF around a closed loop. We said that the definition of EMF around a closed loop is it's the work per unit charge. Integration of F dot ds, that's the work, divided by the charge, work per unit charge, over the closed loop. Now, if you substitute F over Q by E plus V cross B, then you should have two terms that could contribute in principle to the EMF. But we're going to show that this term actually doesn't contribute at all. And so first, the electric field part, we can cut it up into two parts. The E static, electric field due to static charges. Remember the conservative electric field, and its loop integral over a closed loop. Any closed loop is zero. So the only one that will survive when you integrate over a closed loop is the non-conservative electric field. So that's remember, this is the case where integration of E static dot ds around a closed loop is zero. We did this before many times. So it doesn't contribute to the electric field. The electric force, the electrostatic force due to static electric charges can never result in an EMF around a closed loop. So the only two terms that are non-zero then are integration of E non-conservative dot ds due to the non-conservative electric field part, or this one. So let's see this one, if this one is going to be contributing or not. We're going to turn out to be zero. So let's see why it's zero. V is what? V is the velocity of the charges along the wire. So for instance, over here, V is the velocity. It's pointing in the same direction as the wire. So it's pointing in the same direction as ds. ds are elements of length along the direction of the wire. So at this point, the V and the ds vectors point in the same direction exactly. Okay, V cross B is perpendicular to V. Remember, the cross product between two vectors is perpendicular to both vectors. So that means if V is along the direction of the wire, then V cross B has to be perpendicular to the wire. Okay, V cross B is perpendicular to the wire, and you're getting now V cross B dot into ds, and ds is along the wire in the direction of V. That means this V cross B is perpendicular to the ds. When you get the dot product between two vectors that are perpendicular, you get zero. So the whole term is zero. So this V cross B part does not contribute to the EMF around the closed loop when the loop is fixed in space and it's not moving at all. The only part contribution comes from the electric field, conservative electric field. And so that's why we were able to write integration of E dot ds, E non-conservative dot ds. We wrote that as the EMF. That's why it's equal to the EMF in the case when the wires are not moving. And that then gives us a relation, something called Emf Flux Rule, which is the relationship between the EMF and the rate of change at which the magnetic flux changes with time. EMF is minus d phi by dt.